I think it's very important to get students to do lab in the classroom, but sometimes the cost is prohibitive and a lot of schools just don't provide the facilities. And so it's important sometimes to look at labs that are not as costly. For this lab, all you'd really need is a Bunsen burner with a source of natural gas, a couple pliers, and the most expensive item, a bobby pin, or 2 or 3 or 4, depending on how you want to do it. I think it's real important to look at some of the current items going on in science, and one of the big majors where students are majoring in is material science or materials engineering. And one of the courses that they might take in a class like that or in civil engineering is an entire course on steel and how the steel is composed and how steel can vary. Now, why would something like this be important? Some people say that when the 2 towers crashed, the planes crashed into them, that the intense burning of the jet fuel, the heat changed the crystalline structure of some of the steel, and that helped facilitate some of the crash. It's important that when construction engineers are building something with steel, that they use the correct steel for that particular purpose. If you look at chef's knives, they will have a certain type of steel called chromoly steel or moly steel or hardened steel. There are different types of steel. And one of the easy ways to look at that is to look at some of the properties of a bobby pin. What you might want to do is take a bobby pin and just have the students analyze and get a feel for how that bobby pin feels. You can see I let it go and it twists back. It's got some flexibility. Well, it's got a particular crystalline structure. How is that crystalline structure going to change if we heat it? Let's take a bobby pin. But now recognize, in the Bunsen burner flame, it's going to get very, very hot. So what I'm going to use are 2 pliers to hold this. You might also want to recognize that there could be a plastic coating on the bobby pin, and so you might get some smoke out of that. Don't worry about that. It's not going to be dangerous, but some people might worry about that. So let's turn on the Bunsen burner flame. Remember, this flame, when it's optimal, is nearly invisible. And so you have the flame, and you can see that hot part of the flame as the inner cone. So what I'm going to do is take these 2 pliers and just hold it in the flame. And I'm just going to hold it right there. You can see some of that burning off. And you can see that I've got it red hot. Can you see that? And what I'm going to do is I'm going to take it out of the flame and just let it cool. Now recognize that steel will take a little while to cool. And so as I'm doing that, I'm going to turn off the Bunsen burner flame just to be on the safe side. And then what you have to do, and it's pretty tough to see visually, but you want to see if it changes any. And you see that it has lost some of its springiness. And you've had a portion of a crystalline change in there, and that's why it's lost some of its springiness, as they say. Now this is what we call annealing. Annealing is where you heat it to a particular temperature and then let it cool slowly. So you could take this bobby pin, you could have a bobby pin for your standard or comparison, and you could try other properties or other techniques. Turning on the Bunsen burner flame again. Last one, we heated it to red hot, and then we let it cool slowly. And I'm going to put this right over here. Is that appropriate? And I'm going to this time cool it very quickly. I'm going to pull it apart a little and use the pliers. And we're going to quench it. We're heating it in the flame. You can see that it got red hot. And now I'm going to quickly put it in the water to cool it. Are you able to see some of the solid? It's precipitating. What we have here, as I said, is in steel we have multiple types of crystalline structures. We have one type where it will only be able to contain a small part of the carbon. And that's one of the parts of steel, is the amount of carbon that you have. One type of carbon, the amount will make it, well, let's analyze it. Let's look at this and see what happens. We've heated it to red hot, we've cooled it quickly, and let's see what happens. I don't know if you could hear it, but it was very brittle. And so what we've done is change the crystalline structure in a situation where it was not able to, as we cooled it, contain as much carbon. So what we were able to see here is some of that carbon precipitating as iron carbides. And so we're pulling out some of that carbon since the new crystalline structure can't hold it. Now, if you are in an AP class, the handout, the write-up, will talk about some of this in terms of the face-centered or body-centered. So you can get some more details in the handouts, but you can see that it could not contain as much carbon, and so somewhat precipitated. Let's try one more. Got to bend it a little. Hold it in the pliers. Remember, this is going to get very hot, so that's why the pliers are there. Go to heat it. You can see some of that plastic burning off. That's some of the initial flame yellow component. Okay. I've got it red hot again. Now I'm going to cool it in the water just like I did before. Okay, you can still see some of the iron carbide coming out. Now if I would try to break this right now, it is going to be brittle just like the last one. But what I'm going to do now is I'm going to heat it. Well, guess what? We'll have to do that again. Let me just show you. It is very brittle, and what you want to do is, as you cool it, what you want to do is gently heat it in the flame again and hopefully lose some of that brittleness. Let me do this, put this over here. Get it to that red hot part, cool it, then I'm going to gently heat it again. And what you get, I don't know if the camera can see it, but you get kind of a blue oxide coating on it. And then if you let it cool, still a little hot. You can see that, guess what? That brittleness has disappeared and it's gone back to a springy metallic form. Even though before it was brittle, by heating it again gently with that blue coating, we brought back the springiness. And so this is a very cheap, very easy lab that the students love to do, and you can thoroughly get an understanding of steel and then connect it with other things, like carbon steel and knives. And if you even want to go to another level, I have here a particular knife that you could get. It's a ceramic knife, though. It has no metal in it whatsoever. So if you're talking about material science, too bad I can't have you heft this knife, because if you have a great chef's knife, it's pretty heavy, but this is very light. But with the ceramic coating, it's also very sharp. And it's phenomenal in the sense that a chef's knife, you can use a sharpening tool or a steel. You can't do that on this. You have to send it in, free of charge, but They will sharpen it. They have to use a certain steel on that. But you can once again have a connection with chemistry and materials out there in their real world. And if someone likes chefs or cooking, this might be a connection. So try the bobby pin lab. It works great. Thank you.